Hello everyone, welcome to online machine learning sessions. So in this introductory session, we will have a detailed look on the basic and fundamental concepts of machine learning. So we will be starting from the very beginning by first discussing the basic definition of machine learning. Then we will have a look at the different types of machine learning, and then we will see that what steps or the major components involved in a machine learning pipeline. So we will be discussing each and every component in great detail, and then we will conclude this introductory section with some real life examples or real time applications which are using machine learning nowadays in order to solve different types of problems. So now the first question is that what is machine learning? So we can say that machine learning is a branch of artificial intelligence which is mainly concerned with the design and development of algorithms. So what we want is we want to design and develop different types of algorithms related to different types of applications, and those algorithms basically allow computers or different systems to evolve behaviors based on some empirical data. So we have some kind of empirical data, and we will see that there are different types of data can be involved in a machine learning application. So a machine learning application can work with audio data, it can also work with images, it can also work with videos. So depending upon the application we can have different types of data, and based on this empirical data we basically want to develop algorithms that can evolve their behaviors by training and by using different samples of this data. So the basic target in machine learning is to develop an algorithm which could evolve itself or evolve its behavior based on some kind of initial data. And since intelligence requires knowledge, because we cannot build intelligence in any system or application without some initial or prior knowledge. So it's necessary that we should be able to acquire some kind of knowledge in order to generate intelligence. And to have this knowledge, we want to make the systems or computers capable of acquiring this knowledge from the data, right? So the initial thing is that we have some kind of raw input data, and we are trying to extract some knowledge out of that data, and we are trying to, after we have that knowledge, we are trying to build some intelligence into the system so that it should be able to solve different kinds of problems. So this was basically the very basic level definition of a simple definition of machine learning. So if we formally define the machine learning, we can say that it is a subfield of computer science that gives computers the ability to learn without being explicitly programmed, right? So this thing is very important here, that we want the systems or computers to learn or evolve their behavior from some kind of data by passing through some training mechanism, right? We don't want the systems to explicitly being programmed for some task, right? So that's why we are saying that we are basically making our systems intelligent, or we are putting intelligence into the computers. So this is the formal definition of a machine learning. We can also say that a computer program is said to learn from experience E with respect to some class of tasks T. So if I represent here with the experience with E, and I represent different tasks with T, and if I represent the performance measure with P, then if its performance at task T can be measured by P, then it should improve with the experience E, right? So in simple words, we can say that our computer program is learning or improving itself with some experience E, and its performance is being improved on different types of tasks, and we can measure its performance, that whether it is improving or decreasing. So we can say that if we have some kind of data, then we can use that data set, and on the basis of that data our system should be able to answer us some unknown questions, right? So in machine learning terms we can say that we want to have a training mechanism, and that training mechanism is basically our system is using some data, and on that data it is extracting knowledge, and by using that knowledge it is doing the prediction task, and prediction task is basically having the answers of some unknown questions, right? So this is basically the overall goal of a machine learning algorithm, that we want to train a machine learning algorithm on some data, and we want some predictions out of that, so that we can have our the solution of our problem, or we can have the answers of some unknown questions. Okay, so this was the basic and formal definition of machine learning. Now we have seen that in machine learning we are basically interested in developing intelligent algorithms, right? So what are those algorithms? The success of machine learning system depends on algorithms. So we can say that we have developed a successful intelligent system if we have developed a successful algorithm, right? So the performance of any machine learning algorithm is basically bound to its underlying algorithm. The more efficient or the more capable the algorithm is, the more efficient will be our system will be. The algorithms control the search to find and build the knowledge structures. So the basic goal of the algorithms is basically to extract knowledge or to build the knowledge structures, so that it can be able to solve some specific problem. The learning algorithms should extract useful information from training examples. So as I said earlier, that we have some data set. So if we in that data set we have some examples, and we are using those examples as the training examples, and the purpose of those training examples is to extract knowledge or useful information, and those knowledge or useful information will be used to learn the algorithm, and then that trained algorithm will be used in order to make predictions. And prediction is basically means to have some answers of some unknown questions for which we are training our algorithm. Okay, so after defining or having a formal definition of machine learning, now let's see that what are different types of machine learning, and what are the basic concepts which are involved in machine learning. So here you can see that we have a tree-like structure in which we have different branches, and each branch is basically representing different categories or different types of machine learning, right? So in machine learning we basically have three different types, right? If I talk about human supervision, so under human supervision the different algorithms of machine learning can be subdivided into three major categories, right? So these are three major categories, and each category has certain algorithms in it, right? So there is difference in each category, and we will be having a detailed discussion on each of these categories. So a machine learning algorithm can be supervised, it can also be unsupervised, and it can also be a reinforcement algorithm. Sometimes people also say that we have another category here which is a semi-supervised learning. So let's we will see that what is the basic difference between each category, and what are the algorithms which belong to these certain categories. So out of these three categories, initially we will be looking into the supervised learning domain, and we will see that in under supervised learning domain we have different algorithms, and those algorithms are used for different classification tasks as well as regression tasks. So under supervised learning we can have different algorithms that could perform classification, or they can also perform regression.